And welcome back to Archimedes and how he's going to try to deal with determining pi. And he begins, as if you're watching these videos in order, which I hope you are, with a hexagon. Now, why does he want to start with a hexagon? Well, one, it's a pretty good approximation of a circle. Now, you may not think it is, but it's not that far off. So we'll take a look at that arithmetic later. But right now, let's just say he's going to start here, and that's number one, it's a good approximation. Number two, he knows information about a regular hexagon. And notice the word regular is important. All of the sides must be of equal length, all of the angles must be equal going all the way around, and that's going to let Archimedes do the following. And that's what he does. He builds a triangle inside of his circle, inside of his hexagon. Now let's talk about what we know about this circle. Well, we're going to let the circle have any diameter we want, and will be convenient when we choose our number. But because this circle lives in this hexagon, and this hexagon is regular, there's certain bits of information that I know. Namely, that this angle right here, this central angle, I'm going to be able to know the size of it. Well, let's think about it. If I look at a central angle that marks off a complete side, and I know there's 6 sides, I would know that 360 degrees divided by 6 gives me 60 degrees. So the central angle that subtends a side is 60 degrees, but this central angle doesn't subtend an entire side. It subtends half of a side. So I know this angle right here is 30 degrees. Now, because this angle right here is 30 degrees, I know this angle up here is 60 degrees. And remember, we said that this line is perpendicular to the diameter. That being the case, I have a right triangle, 30, 60, 90, and because of that, I have some known ratios that I can put up here and say, hey, I know that triangle has to obey the same rules as this one. And here they are. Let's see if I can remember this today. Well, if I remember correctly, if this is 2, this is 1, this is the square root of 3. And because of that, I'm going to be able to think about any 30, 60, 90 triangle as a multiple of this triangle. When I say multiple, I mean all the sides get multiplied by the same non-zero scalar. So now let's take a look at what Archimedes is going to do with his triangle.